Okay, we're going to hit section 8.5, factoring special products. So first question, what do you notice is the same in all of these? So each item has how many terms? 2. Good. I got 2 terms, 2 terms, 2 terms, 2 terms. There, I got you started. What else do you notice? Yep, the variables, x squared, x squared, x squared, x squared, y squared. Okay. And also, let's look at the numbers, or let's look at the operation. Subtraction, 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 subtraction. Take a look at the numbers, constants. Or the coefficients, actually, both. Perfect square. Square root of 16 is 4. Perfect square. Square root of 100 is 10. Perfect square. Square root of 81 is 9. Square root of 64 is 8. Square root of 25 is 5. Square root of 36 is 6. They all work. They all are perfect. So let's just hold that for a second. I'm not going to write anything there right now. And I want you to go ahead and I want you to multiply this out. Remember, when you multiply a 2 by 2, you're using FOIL. First terms, inside, outside terms, inside terms, last terms. X times x, x squared, that's first term. Outside term, x times a negative 4. I can change it. I'm not sure which way you guys prefer anymore. And inside terms and last terms. Combine like terms, negative 4x plus 4x, 0. Those cancel out, and we're left with x squared plus a negative 16, or x squared. Oh my goodness, look at that, guys. Oh. So we're going to learn how to take this and go backwards to get these. Do you see what happened here? They both started with whatever the square root of this was. Square root of x squared is x. Square root of 16 is 4. And the sign is one of each. So you literally, when you have, it's called a difference of 2 squares. You take the square root of the first, and that goes there. You take the square root of the second, it goes there. 1 is plus, and 1 is minus. And that's how that middle term drops off here. Okay, why don't you guys try that one? Square root of x squared, x. Square root of 100, 10. Now what do I do? 1's plus, 1's minus. All right, multiply this out. Pause it if you need more time. 9 times 9, 9x times 9x is 81x squared. 9x times 8 is 72x, minus 72x, minus 64. Of course, you can change that plus a negative if you want. Gone, and we're left with 81x squared minus 64. Oh dear, are we noticing a trend? So even when there's numbers before the x squared, it still works. If this is a 27, that's not going to work. Square root of 27 doesn't come out even, but square root of 81 does. So 9x and 9x, that works. Square root of 64 is 8 and 8. So they both have to work. Then 1's plus and 1's minus. You guys go ahead and try that one. All right, so the first term here is going to be square root of 25 is 5x. What's square root of 36y squared? 6y. One's plus, one's minus. Doesn't matter what order you do that. So when you notice these things, and it's called a difference because we know difference. Let's move down to this. Difference means subtraction. Difference of two squares. Then you can break them down. Now keep in mind, you can have different powers. So you could have an x to the fourth. That's a perfect square too, because you can do x squared and x squared. But if this is an odd, then that is not a perfect square. But if it is an even, you would just divide it by 2 to get each of them. Okay? So question here, what about the sum of two squares? And, does that work? When you find that you have something that follows this, where it's adding between them. Can't do this. So you cannot do it this way. You cannot. No, no, no. So you're looking to, in order to do this, it has to be subtraction. So don't let that trick you, okay? Sometimes you'll see something and then you're like grooving and you're thinking, oh yeah, oh, look at x squared. Oh yeah, square root. Yeah, yeah, yeah. No, no, no. You have 3 checks you're doing when you do these. Is that a perfect square? Is that a perfect square? Is that a minus? If the answer is no to any of them, you can't do it. So go ahead now, and I recommend you stop the video and try these problems where you're determining whether the binomial, remember binomial means 2 terms, is a difference of 2 squares. So yes or no questions. If so, then factor it. Okay, so again, I recommend you pause the video, try these problems, and then start it back up when you're ready to check them. All right, so when we look at these, is that a perfect square? The p squared is, the 9 is, and the q to the 4th is, but the 3 is not. No. So we had this check and we had this check, but this one was, that term was not a perfect square. Remember, there's 3 checks. This one, check, check, check. Yep, they're all perfect, so we can break that down. So I'm going to set it up. Square root of 100 is 10, and x squared is just x, so 10x. Square root of 4y squared is 2y. One's plus, one minus, doesn't matter which. So it is a yes. And then there is the factoring. Next one. Yes, that's a perfect square. Yes, it's a minus. Yes, it's a perfect square. So we can break this down. And then I'm going to have x squared, x squared. Notice that it was x to the 4th. So remember I said just divide it by 2 and you'll get each one. Square root of 25y to the 6th is 5y to the 3rd. And we are done. Sometimes you can even keep going. So you always, like here you can't yet, but it might be possible. Let's see. So this is going to break down. Check, it is. It's subtraction, it is. So we can break it down. X to the 4th becomes x squared, x squared. One's plus, one's minus. Y to the 4th becomes y squared and y squared. Normally you would say done, except that when you look in there, you're like, wait a minute, I got a lot of perfect squares Perfect, 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 perfect. So can I break these guys down more? Maybe part of it. That has a plus. No go. Done. So that's just there. So I'm going to leave that because that's part of my answer. There's nothing more to do with that. Okay? But this is check, minus, check. It's got all three checks. So I can break that part down. This part I'm breaking down again. Okay? So the square root of x squared is x and x. Square root of y squared is y, and minus and plus. That is finally the answer. So sometimes it's one part of it can keep going and the other part just stays the same. All right, so now we are going to turn the page to another part, another type of special factoring. And that is right here. Again, what do you notice is the same in all? Do you notice any perfect squares in there? I do. Perfect square, perfect square. So the first and the last, perfect square, perfect square. First and the last, perfect square, first and the last again. Okay, what else do you notice is exactly the same in all three of them? If they all have three terms, they all have x squared, x and a number, x squared, x and a number. They're all trinomials. What about the addition or subtraction? Is there anything that's the same in all of them? Yes, this. This is the same. 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 Right? So there are some things going on here too. First, I want you to take, and I want you to notice, when you multiply x minus 7 times x minus 7, notice I'm going back to this for a second. This isn't the same. Okay, the difference of squares, we had one of each. So I'm not asking you to do the same thing you did when you multiplied these. These were one of each. These are the same. So can you multiply that, please? All right, so foiling again. X times x, x squared. X times a negative 7 is negative 7x. Negative 7 times x is a negative 7x. Negative 7 times negative 7 is positive 49. Again, if you get tripped up with the negative signs, just change them to keep, change, flip, keep, change, flip. I'm going to combine like terms, and I've got a negative 7x and another negative 7x, so that's a negative 14x plus 49. Oh! What do you see? Wow! But how would you take this and get this? And get this? Like, how could you do that? What do you see? Part of it's the same as the other one, isn't it? This is called a perfect square trinomial, which you're going to see down here. Perfect square trinomial. And I want to go back to this one for 2 seconds because I'm bothered by the fact that I did not go in here and highlight this term, difference of two squares. That's a very common term that you should be familiar with. And then here is the formula for that right here. So now we're going to get into what's called perfect square trinomials. So there's 3 terms. The other ones only have 2 terms. These have 3. But one thing that is the same, as you will notice, is it is going to break down again because we know that from here. But what did we do? That would be x and x, 7, 7, and as far as if you notice they're both the same sign, so how would you know which sign? It's whatever is right here. So it's x minus 7 times x minus 7, which can also be written like that. Either way is fine. Okay, but what I guess I want to talk about too is how do you know it's a perfect square trinomial by looking at it so that you would know you can do this. So this is 4 checks. So just like when we were doing this, we said, okay, there's 3 checks you're doing, right? Where did we do that? Down here, where we were like perfect square, subtraction, perfect square. 3 checks. There's 4 here. So the first thing you want to check is, is there a perfect square? Check. Is the last term a perfect square? Check. Is the last addition, is that addition? Check. Now the fourth one is a little bit trickier, but it's still not too difficult. I want you to tell me, it's called the smiley face. What is the square root of 2x squared? 4x squared. 2x. Okay, put it in a box. What's the square root of 25? 5. So your 2 little eyeballs. Now when you multiply those together, what do you get? 10x. When you multiply that by 2, and you will always multiply it by 2, that doesn't change, what do you get? 20x. Does that match the middle term? Check. That's the fourth one. So you're going to multiply them, and then this multiplying it by 2, that's the same no matter what problem you do. So when you're done, here's the reality. You have it almost set. So when you did these 4 checks, you have it almost set to put your answer because you got the square root here and you got this number here. The only thing I need is how do I figure out what sign it is? Right there. So it's going to be a plus. So I've got it laid out here. I just need to write it now. 2x plus 5. Oh, that's right. We said put the little, what did somebody call it? I can't remember. They said put the, I can't remember. Kids came up with an idea for the little 2 up there. Because what you would have then is 2x plus 5 times 2x plus 5, which is the same as that. Okay, so I think it helps once you kind of see me go through a couple, because I know that can sound really confusing, and you probably are confused right now, but hang in there, okay? Stay positive. Let's try the next one. Let's check it. First thing, is that a perfect square? Yes. So we're going to put it in a box. Check. Is that a perfect square? Yes. Put it in a box. Check. Is the last sign addition? Check. Now do the smiley face. Multiply those 2 and get 6x. And what do I do with it now? Times it by 2, and I get 12x. Is that the same as that? It doesn't matter about the sign. Check. Got my 4 of them. I'm basically going to now put the ears and the top. That's it. It was ears and a top hat. That's what the kids said. You're like, okay. Ears and the top hat. And the subtraction goes there. We're searching a little. We're pushing this a little bit, but if you have eyes to see, you can see the eyes, and the smiley, the little nose, the ears, and the top hat. All right, let's keep going with this. I know that's not cemented yet. I know that for a fact. So here is the perfect square trinomial right here. And they give you the 2 scenarios, right? Where you end up with, I'm going to go back up here so you can see this. When we had a minus raised to the 2nd power, remember you had a minus up here. And that's the only thing that's different is when that minus is there, that minus is there. And likewise, when there was a plus up here, there was a plus in there. So when there's a plus in that spot, it's a plus there. These are always plus. Okay, these are always perfect squares. All right, so what if you have a difference at the end? Just like the other one, you can't do it this way. These are special circumstances, and it's kind of one of those things that as you get better at math, you see things better. You know, you just like with number sense, the more you work with numbers, the more you start to see certain calculations and divisions in your head, and you become more familiar with them. And it's the same thing with these types of things. You start to see them, and you're like, oh, I like those numbers. Oh, let's see. Square root of that is x, square root of that is 7. That's 7x, double it. Oh, it is. It's a perfect square trinomial. So now your turn to practice. See if you can figure out, there's 4 of them here. See if you can figure out if the trinomials are perfect squares, and then if your answer is yes, factor them. So again, when I say, okay, I can do this. When I say factor them, I'm saying this. What's your answer? So again, I would pause the video and then restart it, because I'm going to just continue on and go through them. But you really should take some time to try to do them. All right. Here we go. Is that a perfect square? Yes. 3x. Check. Is that a perfect square? Yes. 8. Check. Is this a plus? Check. Multiply those. 24x. Multiply it by 2. 48x. That is not a check. I'm sorry. 48x is not 15x. My answer is no. All right, how about this one? Let's try this one. Square root of 81x squared, 9x. Check. Square root of 25, 5. Check. Last thing, addition. Yes, operation is the word I was looking for. Make your smiley and multiply. 45x times 2, 90x. And check. I got my 4 checks. Time to make the smiley. I look for this sign because that is what goes in there. Put my ears on and my top hat, and we're done. Rewrite it so it's legible. Okay. Next one. These are kind of fun. Come on. Once you get used to these, they're kind of fun. Square root of 36x squared is 6x. Check. Square root of 14. No go. There's no perfect square there. And the last one, square root of 4x squared is 2x. Check. Square root of 1 is 1. Check. Last thing is a positive. No. So there you are. And if you're questioning or wondering, could this be could you have written it like this so that they're separated? Because those two things are the same, right? Whenever the squared is on the outside of the parenthesis, that's this times itself. You can write it either way. All right, there is one more problem, and I believe it's on the back. So let's take a look at the word problem here. Those are always the best. A square piece of cloth must be cut to make a tablecloth. The area needed is 16x squared minus 24x plus 9 inches squared. The dimensions of the cloth are in the form cx minus d, where c and d are whole numbers. Find an expression for the perimeter of the cloth when the perimeter, find the perimeter when x is 11. Whoo-wee! Well, we have a square. Well, or maybe you don't have a square because you draw like Mrs. Silva, but yes, we're going to try our best. Here is this key phrase, square, square. When we grab, I have to grab it. Where did it go? Oh, it's on the other side of this. Hence the name, perfect square trinomials, you guys. It's because you get two things multiplied together that are exactly the same. That works perfectly when you have a square, because they're the same. So that's why we call it a perfect square trinomial. So if you are dealing with a problem where we're talking about a square, that is the perfect time for your brain to send those alarms off saying, perfect square trinomial, perfect square trinomial. Okay, so that means I'm going to check, and since they told us here C and D are whole numbers, you guys know what whole numbers are, right? 0, 1, 2, 3, and so on. So we don't have to worry that these are going to be some weird fractions or something. So let's look at this. Is that a perfect square? Yes. Check. Is that a perfect square? Yes. Check. Is that a plus? Check. Make your smiley face and multiply. 12x times the 2, 24x. Check. I got my systems in order here. We definitely have a perfect square trinomial, so I just need to add the nose, the ears, and the top hat. 4x minus 3 squared. Yes. Because that is, it said this is the area. It looks too big up here. That is the area. Area of a square is side squared. Area of a square is side to the second. Well, you have side to the second. So each side here is 4x minus 3. Well, so what's this side? Well, 4x minus 3. Of course, I have the whole thing. So it says find an expression for the perimeter. Well, I can do that now. Add these all up. How many x's do you have? 4, 8, 12, 16x. And then minus, how many 3's? 3, 6, 9, 12. There's the perimeter. Great. I've answered that part of the question. Find the expression, because half the time people don't answer all the questions. Find an expression for the perimeter. Done. Whoops, I want the reduced one. Oh, that is reduced. Well, okay. Yes. Now, find the perimeter when x is 11. Well, that's simple as can be, because now I'm just going to put in 11 for that. Which we could do it separately too. We could do 11, 4 times 11 minus 3. So we could do 44 minus 3 is 41 times 4, 164. Or we could do it this way, 16 times 11. Well, that's 160, 171 minus 12. No, that's not right. $176 minus 12. There we go. All right, so then that would be 164. Same thing either way. So I can use the formula I had to get here anyway for the whole perimeter by adding these up, and plugging in the value they gave us. Or I could have found one side and then multiplied it by 4, which is what I did here. Same answer, doesn't matter. All right, again, feel free to go back, rewind, and pause it if you need to go through it again. All right. See you soon. Bye.